So we've got two functions. It says state the domain and range of each function, sketch the graph of each composite function, and then state the domain and range of each composite function. So if we were starting off, and I guess we'll color code these again, we'll make g of x in blue, f of x in green. If we think about these graphs, okay, and I'm going to rewrite g of x with the x squared first plus 4. If we think about our transformations, and this is why I like ending with this unit, because this unit reviews our first unit a lot. And right before the exam, that's kind of nice. So how do we graph negative x squared plus 4? Well, if we move from left to right, the negative would flip it down, and then it would get translated 4 units up. So in your mind, you should be able to get a quick sketch like this. So for g of x, our domain is everything, and our range y is less than or equal to 4. And a quick sketch of f of x. How do you graph y equals x plus 1? Well, it's a line, y-intercept of 1, slope of 1. What do we know about domain and range of a line? The domain is everything. The range is everything. So then to figure out and to be able to graph each composite function, unlike the adding, subtracting, and multiplying and dividing, where we took the two graphs and either added the y values or multiplied the y values to find out the new graph, with composite functions, it will always be easiest if you find the explicit equation first and then look at that equation and say, how do I graph that? Do I know how to graph that? So for part A, the explicit equation for f of g of x. Composite functions, we always start in the middle. So that's our g of x. What is g of x equal to? G of x was 4 minus x squared. Then we plug 4 minus x squared into our function of f. What does f always do? It says whatever you plug into it, you add 1 to it. So if we plug in 4 minus x squared, it's going to equal 4 minus x squared plus 1. Because the function f of x says whatever you plug in, add 1. So if you plug in 4 minus x squared, we take 4 minus x squared and add 1 to it. Simplifying this becomes 5 minus x squared. What is that graph? Well, if we were graphing, if I rewrite it here, f of g of x, I could write the minus x squared first plus 5 so that it fits with our transformations. That's going to be a parabola that gets flipped over the x-axis and then moved up 5 units. And there's our new graph. I don't think it's easy to tell the domain and range just by looking at the two original graphs. If I put them together, I can't see that it's going to be what it is. But once we get the explicit equation, it's not going to be bad to graph that. And now for this function, we can see the domain is still everything. But now, wow. Our range is less than or equal to 5. B says do f of x. Same process as before. We want to find f of x. Start from the inside. Well, f of x is the function that says whatever you put in, you add 1. So f of x is equal to x plus 1. And if you put an x plus 1 into f of x, it says whatever you put in, add 1 to it, this just becomes x plus 2. Can you see that that's another line with a slope of 1, a y-intercept of 2? Domain for this line is everything. Range is everything. Questions you can do for practice are number 4.